ASCAT is our advanced stress concentration assessment tool. What it is it allows us to predict stresses and strains above a material's yield strength. If I use this paperclip to explain, a ductile material like a metal will, if you put a bit of force on it, it'll spring back to where it started. This is the elastic part of its behaviour. And then if I continue to pull it, it starts to permanently deform. This is going past its yield strength. And a linear finite element analysis cannot predict the stresses and strains above this point. When we're analysing structure, we'll find there are stress concentrations around features, and these are not always a problem, but a linear finite element analysis would give us very high stresses. Non-linear analysis can be used to predict the behaviour, but it's very expensive, very time consuming, and its use is limited on aircraft structure. What ASCAT can do is accurately predict stresses above a material's yield strength without resorting to non-linear analysis. Instead of waiting perhaps 2 days for a FEM to run, it can run in minutes. This allows you to iterate to improve your design, so you can make small design changes and assess them quickly. And then once you've got your final design ready, you can run non-linear analysis for your final certification.
So before you'd have to extract the stresses yourself, and then you would convert them, so you'd do it in different software, Excel or something like that, calculate your new stresses, and then you'd be able to check whether they were acceptable. Whereas now it's all done inside the main FE software, and it's done for you. It saves time, saves effort for the individual, and it makes it a lot easier to communicate to other people. If you have to convey that information to others in your department, you've got a very easy way of displaying the information and sending it to someone else.
It also takes guesswork out of engineering. So in lesser structure, one might use engineering judgment to say, this is a stress concentration, but I'm happy with it. Using ASCAT, we can take out that judgment and quantify the magnitude of the stress. To validate the ASCAT and show it's performing correctly, it was very important to get good test data, good real material test data. As part of the NATEP project, we had a test program and we used digital image correlation to show the strains that are happening in the test and then relate these to stresses and validate our model and the FEM. Digital image correlation is when you spray a random pattern onto your test specimen, and using footage from the test, the image correlation detects movement between the pattern, and this will give us the strain within the material, which can then be related to a stress. Because ASCAT is so quick compared to non-linear analysis, it can be used to optimize designs, so saving significant weight in the time permitted to do the analysis. Normally this would take a very long time. If a FEM non-linear run might take 2 days, where ASCAT might take 10 minutes. You can do many design iterations, getting the weight out of structure and ultimately dropping the weight of the aircraft and the carbon emissions.